Hello everyone, this is Amina. Uh, Today's session is 25. We are going to deal with the entropy and temperature diagram. So let's have the relation between the entropy and the temperature. What is entropy? Entropy of a system, molecular kinetic interpretation of the entropy, and the temperature effects. So recap on the introduction of the entropy. Second law of thermodynamics, material systems gives free energy and different forms of energy. Today's learning objective is to understand the order of the materials and to describe what the relation between entropy and the temperature effects. So the session outcome will give the information about entropy and its variation against temperature. What entropy is? In statistical mechanics, entropy is an extensive property of a thermodynamic system. It quantifies the number ohm of a microscopic configurations known as microstates that are consistent with the macroscopic quantities that characterize the system, such as its volume, pressure, and temperature. Under the assumption that each microstate is equally probable, the entropy S is the natural logarithm of the number of the microstates multiplied by the Boltzmann's constant. So formally assuming equivalent microstates, S is equal to Kb into ln of Ohm. So the second law of thermodynamics states that entropy of an isolated system never decreases over time. So isolated system spontaneously evolves towards thermodynamic equilibrium, the state with maximum entropy. Non-isolated systems like organisms may lose entropy provided their environments entropy increases by at least that amount so that the entropy either increases or remains constant. Now, entropy delta is change in entropy is strictly valid only for reversible process such as used in Carnot engine. However, we can notice delta is precisely even for a real irreversible process. The reason is that the entropy S of a system like internal energy U depends only on the state of the system and not how it reached that condition. Entropy is a property of a state. Thus, the change in entropy delta S of a system between state 1 and 2 is the same no matter how the change occurs. We just need to find out, imagine a reversible process that takes us from the state 1 to state 2 and calculate delta S for that process. That will be change in entropy for any process going from state 1 to state 2. The entropy of a system is reversible process that at delta S is equal to Q divided by T. So we have the state, look at the figure state 1 and state 2. So delta S reversible and irreversible is given as delta irreversible is equal to delta S reversible. So we can write S2 minus S1. So irreversible process has the same delta S. Now molecular kinetic energy interpretation of entropy. So what is this entity that flows through matter and depending upon how much it is contained in it, causes it to seem warm or hot to the hand. For more than 200 years, one has attempted to explain thermal phenomena by the movement of the atoms. The image is as follows. The more a body is, the more intensely and randomly the atoms oscillate, spin, and swirl, the greater the agitation, the worse the atomic disorder. So you can have see that assembly of the particles well ordered in every way. Whereas second is that positions and increasingly perturbed, motion increasingly disordered. Then we have the particles increasingly different type, orientation and agitation. So we have the temperature. Also temperature and entropy are closely connected. While entropy is a measurement of the amount of atomic disorder contained in a body, so the temperature describes how strong the atomic agitation, that means the intensity of random particles motion is. Temperature is something like a level of agitation that is low when the atoms and molecules are gently oscillating and rotating. It is high when atomic motion becomes hectic and turbulent. Temperature in a body can be compared to the strength of the winds in the atmosphere, with low values when the leaves rustle but higher ones when branches start swinging. Just as high winds can break whole trees, high temperature can cause atoms to tear away from their bonds. Would you got this point? Yes. The more order disorder is to put in a body, the higher the temperature will be in general. To create entropy or to increase this order in the body by the amount delta Sc, a certain amount of work must be expended. This is understandable considering that gas particles are accelerated, internal oscillations initiated, rotations increased, and the bonds between the atoms broken. The energy need will be greater depending on how many atoms are to be moved and how many bonds down. This means that W1 minus S of E. Now we have the graph here. So total amount of entropy added to the sample can be obtained by adding up all the amounts of entropy that have been created over all time spans. The summary, the entropy of the system increases with the increase in the temperature we concluded from the summary. Next we have the numerical problems, that is multiple choice based questions. So you can look over it. Thank you.